This isn't really a new lesson. Instead, it's just an extension of what we've already covered, and I hope that you enjoy the ride. All right, so we'll start off with just an example. I think this is from the textbook. All right, and it's a story about a roller coaster where, as it's going around its loop, you notice that at the bottom of this loop, it suddenly has a g-force that's 3.5 times greater. All right, and we know that at the bottom, it's traveling at 26 meters per second. The only thing we don't know of is what is the radius. Okay, and we would just want to do that backwards calculation. All right, that's all we're really doing in our homework tonight. It's just taking the stuff we've learned from earlier and just rearranging in a way that helps us solve the problem. As usual, before you start the problem, always start off with a free body diagram. All right, so the box represents the roller coaster itself, and what you define as positive is always towards the center of rotation. All right. So in this case over here, upwards would be our positive direction. There are two forces acting on the roller coaster itself. First off, the track, also known as the normal force, and the force of gravity acting on the roller coaster. Okay, and after done with this, we create our general equation. Our F net is equal to Fn minus Fg. Now our Fn over here isn't just regular Fn, this is centripetal F net. All right, so our F net is equal to one of three equations. Since we're trying to look for V, we probably want to use the one which is mv squared all over r. Okay, and yeah, we are trying to solve for the radius. Okay, so we will be subbing that right into here. Another interesting thing is that because our normal forces are 3.5 times its regular normal force, that's all we're going to sub into here, just 3.5 Fn. So once we're done subbing all that stuff in here, we get an equation that looks like this. Okay, mv squared over r is equal to 3.5 Fg minus Fg. Yes, that simplifies down to 2.5 Fg. All right. And through careful rearranging, we can isolate for r. Pause, unpause, and I hope you get the answer of, 28 meters. Okay, so your entire homework for tonight is just going to be stuff like this. All right, just taking what you've already known, rearranging it to your favor. But before I end off, I want to show you two cool things. All right, I eventually want to talk to you about what a vomit comet is, but before that, I want to show you a really neat feature on all Samsung cell phones. All right, let me just pull up the screen. There it is. Now when you go into the phone menu, there's a secret menu. Some of you guys might know of this. And to get into the secret menu, you hit star pound 0 star and then pound. All right, so star pound 0 star pound, and you get into this diagnostic menu. And it does stuff such as it tests to make sure that all your pixels are working for red, green, and blue. I think you can also activate the camera. Does it cast? Oh, it does cast. Oh, you can see me from right over here. And if you want a preview of what the studio looks like, there you go. All right. So that's how everything's being recorded right now. Oh, 2 copies of me. That's pretty neat. How do I get out of here? I think there's this button here. Come on. There you go. Okay, but what I really want to show you is the sensor button. So once you hit the sensor button, now it only shows you numbers here, and I think most of us don't really comprehend things just by seeing numbers, especially when they're moving that quickly up there. There's a cool feature called graph, and it'll graph out for you what the acceleration is in each of the dimensions. So if I leave the cell phone straight like this, you'll see that acceleration happens in the blue dimension. After all objects are accelerating down to the Earth at 9.81 meters per second squared. Or if you really want to be negative, take the cell phone and flip it around, and you can see that the blue axis goes down below. If you want to influence the red axis and green axis, I think you need to deal with another dimension, such as the landscape mode. I guess that affects the red axis, and I guess the last one will be portrait mode, which will be the green dimension. Of course, that's not the cutest thing of showing this. Instead, what's more fun is just showing you that if I glide this left and right, you can see that the red axis is this dimension over here, and the up-down axis is described by the blue. And lastly, the stabbing dimension is the green axis. All right, so it'll track all this information over here. And I want to correlate this with our next example, which is the vomit comet, which is the definition of what is really free falling. All right. Now, believe it or not, the moment I let go of the cell phone, when I toss it upwards, that's when it experiences real free fall. But it's very difficult to throw a cell phone up into the air and allowing it just to remain in the same orientation without it rotating. All right, because when you rotate it, it's just going to add extra values that you don't want there. All right, so it's very difficult just to throw it up. Instead, I'm just going to show you free fall from just dropping it from up here all the way down to my lap, and I hope I don't hit anything along the way. Okay, so take a look at the values there. And if you take a look, there's a small little blip on the screen, if you zoom in carefully, where the values of all 3 dimensions go to 0. That's what free fall is. All right, and that's when I want to direct to this next thing called the vomit comet and the common misconception in it. There's this airplane that's well known in NASA, which is used to train astronauts so that they can experience 0 G's without going, to the space station or anything. All right, and what the plane does is that it goes through this cycle that looks rather sinusoidal. All right, because the common misconception that people think of is that in order to experience 0 G's, you need to sit in an elevator or stand in an elevator and have someone cut the line and let the elevator free fall. Okay, yes, that's true. You are free falling there, but anytime you take an object and you throw it, the moment you let go of it, it's experiencing free fall throughout its entire journey. So they use that hack here in the plane, because if you just allow it to fall like this, the plane doesn't have that much time before it has to turn up again or it'll crash in the ground. All right, so they allow it to experience this free fall for a much longer duration in time by allowing the plane to first off accelerate upwards, and then they shut off the engine. All right, so during its entire parabolic travel, at least when you're inside the plane, you can't tell here that you're flying in a parabola. All right, instead you are literally free falling in the plane throughout the entire journey. And to prevent the plane from crashing around, they quickly turn on the engine again over here. Oh, there's my airplane. All right, and increase the g-forces quite significantly so you don't crash the ground, and then it'll turn off the engine, and then you just do this over and over again until you vomit, and that's why they call it the vomit comet. All right, so I hope you learned 1 or 2 new things here. Make sure you do your homework, and please read ahead, and I'll catch you in the next episode. Bye now.